Today's lesson, we're going to talk about solving absolute value inequalities. So yesterday we talked about equations. Today we're talking about inequalities. And we're going to be able to answer probably by the end of the lesson tomorrow, what are the two ways to solve an absolute value inequality. Today our standard for mathematical practice is modeling. We're going to be seeing a lot of graphing here today in ways that we represent our equations. Okay. So we're going to do the Explore section and probably explain one today. So visualizing the solution of a set of an absolute value inequality. You know that when solving an absolute value equation, it's possible to get two solutions. Here you explore what happens when you solve absolute value inequalities. So we're supposed to determine whether each of the integers from -5 to 5 is the solution of the inequality. Absolute value of x plus 2 is less than 5. So what we're doing is checking to see if this is true for, oops, sorry, it's a 5, not a 2, for all of those numbers. So we're supposed to write yes or no for each number in the table if a number is the solution plotted on the number line. So we'll put in a -5. Absolute value of -5 is 5, plus 2 is 7. So 7 is not less than 5, so it's not a solution. And put in a -4. Absolute value of -4 is 4. Plus 2 is 6, which is not strictly less than 5. Absolute value of -3 is 3, plus 2 is 5, but it's not less than 5, so that's also a no. If there was an equal to there, it would have been a yes. -2, so absolute value of -2 is 2. 2 plus 2 is 4, which is less than 5, so that's a yes, and I can plot that one on the number line. Putting in a -1, absolute value of -1 is 1. Plus 2 is 3, which is less than 5, so that's a yes. Putting in a 0, absolute value of 0 is 0, plus 2 is 2, which is definitely less than 5. Putting in a 1, absolute value of 1 is 1, plus 2 is 3, which is less than 5, so that's a yes. Put in a 2, absolute value of 2 is 2. Plus 2 is 4, which is less than 5, so that one's a yes. And then put the absolute value of 3 is 3, plus 2 is 5, but it's not strictly less than, so that one's a no. Put in a 4, absolute value of 4 is 4, plus 2 is 6, which is not less than 5. And absolute value of 5 is 5, plus 2 is 7, which is not less than 5. Okay, then we're going to do this again. Slightly different equation this time. So we've got the absolute value of x plus 2. We're checking to see if it's greater than 5 this time. So all they did was really switch this inequality here. So we put in the -5. So absolute value of -5 is 5. Plus 2 is 7, and that is greater than 5. So that's a yes. And we're going to put in the -4. Absolute value of -4 is 4, plus 2 is 6, which is greater than 5, so that's a yes. Okay, we put in the -3. Absolute value of -3 is 3, plus 2 is 5, but that is not strictly greater than 5, so that's a no. Put in the -2. Absolute value of -2 is 2, plus 2 is 4, so this is a no. And we would really know that we're doing the exact same equation, except our inequality sign is flipped. So all of these ones in here that are yeses are going to flip to nos. So we're going to flip them all to nos rather than going through each one. Putting in the 3 is going to be the same as putting in the -3. And hopefully you notice that the ends here, they're going to be the same. So this is going to be yes and yes. Okay. So let's see what the part C says. State the solutions of the equation absolute value of x plus 2 equals 5 and relate them to the solutions you found in the inequalities in steps A and B. So if we were actually to state these solutions, first thing I would do would be to add the 2 to the other side. No, so I've already subtract the 2 from the other side. So you'd have the absolute value of x equals 3. And then remember, we do a positive expression and a negative expression. So our solutions would be 3 and -3. And if you'll notice, in here, the 3 and the -3 happen to be the same in both of those. So they're the only solutions that are not included in either one. So these are the only solutions these are the only, sorry, not solutions. Let's use numbers. Not included in the solutions to absolute value of x plus 2 is less than 5 and absolute value of 2x plus 2 is greater than 5. If x is any real number and not just an integer, the graph of the solutions absolute value of x plus 2 is less than 5 and absolute value of x plus 2 is greater than 5, we're supposed to graph all the real numbers. So we've talked about the inequality a little bit before, and remember, if it's a less than or a greater than, it's an open circle. And if it's a less than or equal to or a greater than or equal to, we would have a closed circle. Might not be a bad idea to write that down. Okay. So if we went back here to where it was, this first one, notice it's everything in between those two numbers. So the way we would graph that is we would put an open circle over the -2, an open circle over the 2, and connect them with a line. This one was everything that was to the left and everything that was to the right of the 4. And again, they were both open circles. So open circles on them, and to the left of the 4 and to the right of the 4. All right, so let's reflect a little bit. It's possible to describe the solutions of absolute value of x plus 2 less than 5 and absolute value of x plus 2 greater than 5 using inequalities that don't involve absolute value. For instance, you can write the solutions of absolute value of x plus 2 less than 5 as x greater than -3 and x less than -3. Notice the word "and" is used because both must be greater than -3 and less than 3. How would you write the solutions of x plus 2 greater than 5? Explain. All right, so this one here is, so we would say that it's x greater than 3 or x less than -3. And that we would use the "or" on that because it's going in, it doesn't overlap. So let me explain what I mean by that. So this was the first one here that they were talking about, where it has to be between the two numbers. So really the arrows would be pointing toward each other and overlap. Here, it's either the solution is to the left or to the right. There's nowhere where they actually would cross. So this is because you use "or" because x must be either less than -3 or greater than 3, but not both. So use "or" because x must be either less than -3 or greater than 3, but not both. Describe the solutions of x plus 2 less than or equal to 5 and x plus 2 greater than or equal to 5 using inequalities that don't involve absolute value. So really what's going on here is it's the exact same solutions, but we have an equal to sign in there. So we would say, for the first one, we would say x is less than or equal to 3 and x is greater than or equal to -3. And for the other one, we would say x is less than or equal to 3 or x is greater than or equal to -3. Okay. Now we're going to look at a little bit more graphing through Explain 1 because we're going to solve absolute value inequalities graphically. You can use a graph to solve an absolute value inequality of the form where f, the function f is greater than g, or the function f is less than g, where f is an absolute value function and g is a constant function. Graph each function separately on the same coordinate plane and determine the intervals on the x-axis where the graph lies above or below. For f greater than g, you'll want to find the x values for which the graph of f is above the graph of g, and for f of x less than g, you'll want to find the x values for which the graph of f of x is below the graph of g. So we're supposed to solve this graphically. This over here on the right side is the f of x, and on the left side is considered the g of x. So you can see that they took their vertex here. Remember, we learned how to graph these the other day. Opposite sign, same sign. So the vertex was -3, 1, so that was here. And then they counted the slope up 1 over 1 to do their v graph. And then this is just a horizontal line at 4, okay? So it's saying the inequality of the form f of x is greater than g of x. So to determine the intervals on the x-axis where the graph f of x equals x, absolute value of x plus 3 plus 1 lies above the graph of g of x equals 4. So we're looking at where the f graph, the solutions to it lie above the g graph. Oops, sorry. That's not where I was supposed to shade. There we go. Oh, I don't think it'll let me erase now. Nope, it won't. It's going to make me delete everything. We're just going to use a different color. Sorry. So we're looking at above. Why is above the graph? Oh, I was right the first time. So we're going to look at here and here, because it has to be above, because the other solutions would be below. So the graph of f of x equals x plus 1 lies above the graph. So see how this piece here is above the graph? So we're looking at the solutions that are in between the two there. To the left of x equals -6, and to the right of x equals 0. And we're literally reading those points right off the graph where they intersected. And notice it's just the x value. So the solution of is x less than -6 or x greater than 0. So really the x less than -6 is there, and the x greater than 0 counts for that piece. All right, so now we've got the inequality of the form. So now they're saying that f is less than g, so we have to determine where that is. So determine the intervals on the x-axis where the graph of f of x equals the absolute value of x minus 2 minus 3 lies. That means we're lying below this time. So lies below the graph of g of x equals 1. So the first thing I need to actually do is actually graph this. So looking at the vertex point here, opposite sign, opposite sign, same sign. So opposite sign's +2, same sign is -3. The slope in front is a 1, so I'm going to go up 1 over 1. Okay. And then we also want the graph of x. So this is the f. All right. The g is at 1. So we're looking at the points of intersection, which would be, so I missed a little bit. It looks like -2 and +5. So the graph lies, we would want to say, below the graph of g of x. So where's this red graph line below the green graph, or the blue graph is between those two x values. So between x equals -2 and x equals 6. Let's see, I did something wrong. Up 1 over 1, up 1 over 1, up 1 over 1. Oh yeah, my v is way off. Let me fix my v. Okay, let's try that again. You got to be precise with this stuff. It's being a little too sloppy. So up 1 over 1, up 1 over 1, up 1 over 1. There we go. That's better. Okay. So that was the other place where they cross, so 6. So the solution of x, absolute value of x minus 2 minus 3 less than 1 is where x is greater than this lower number here, because we're looking at these values that are underneath. So x is greater than negative 2, but less than the negative 6. All right, and that's as far as we're going to go ahead and go today. We're going to save the rest of it for tomorrow.